welcome to The Explainer. Today we're tackling one of the big ones. We're diving into one of the most famous and frankly mind-bending concepts in all of science, Albert Einstein's theory of relativity. And this is a story about how one person's imagination didn't just tweak physics, it completely rewrote our understanding of the universe.
You know, for the longest time, for over 200 years, Isaac Newton basically wrote the rulebook for the universe. It was a neat, tidy, predictable place. Space was this fixed, absolute stage, and time, well, time was like a giant cosmic river, flowing at the exact same rate for everyone, everywhere. That was the foundation of everything. But then, right around the turn of the 20th century, a huge crack started to show in that perfect picture. And it all began with a surprisingly simple puzzle about something we take for granted: light.
And the person who was about to blow this whole thing wide open, well, he wasn't some famous established professor. He was a humble patent clerk named Albert Einstein.
So here was the puzzle. No matter how they tested it, experiments kept showing that the speed of light is a cosmic constant. Think about it. If you're on a speeding train and you throw a baseball forward, its speed is your speed plus the speed of your throw, right? But light doesn't work that way. It doesn't matter if you're standing still or racing towards a light beam in a rocket ship, you'll measure its speed as the exact same number. It was a total paradox, and it broke the rules of Newtonian physics.
So to solve this massive contradiction, Einstein came up with not one, but two incredible theories. First, in 1905, came special relativity, which dealt with the weirdness of constant speed. Then, a decade later, he unveiled his masterpiece, general relativity, which completely redefined gravity itself. We got to start with the first one.
Okay, so let's jump into that first revolutionary paper from 1905. This is the one that deals with all the truly strange things that happen when you start moving really, really fast.
So, Einstein started with just two incredibly simple ideas, or postulates. The first one is pretty intuitive. The laws of physics are the same for everybody who's moving at a constant speed. But the second one, this was the radical leap. He said the speed of light is the same for everyone, no matter how fast they're moving. He didn't try to explain why, he just asked the question, okay, let's just assume these two things are true, what are the consequences?
And the consequences are just completely wild. If you accept those two simple starting points, then reality has to be way stranger than we ever imagined. It means time itself must slow down for things that are moving. We call this time dilation. Moving objects literally have to get shorter in their direction of motion. And get this, two events that seem to happen at the exact same moment for you could happen at different times for someone else moving past you. The universe, it turns out, doesn't have one master clock.
And dropping right out of these ideas is maybe the most famous equation in all of history, E equals mc squared. This isn't just a formula. It's this profound idea that mass and energy are just two sides of the same coin. They're interchangeable. And this one idea, this beautiful, simple equation, is what ushered in the nuclear age. But special relativity had a big piece missing. It worked perfectly in a universe without gravity, which, is a pretty major thing to leave out. So Einstein spent the next decade on his true masterpiece, the general theory of relativity. And his journey started with what he later called his happiest thought. He imagined a person in an elevator whose cable had just snapped. In that moment of free fall, they would feel completely weightless, right? Just floating. And he realized that state is absolutely indistinguishable from floating in the zero gravity of deep space. That was the key insight, this equivalence between gravity and acceleration.
And that leads to this mind-blowing conclusion. Gravity is not a force. It's not some mysterious invisible rope pulling things together like Newton believed. No. Instead, massive objects, like the sun, literally bend and warp the fabric of space and time around them. Think of it like putting a bowling ball on a trampoline. It creates a curve. Now, if you roll a marble nearby, it's not being pulled by the bowling ball, it's simply following the curved path in the trampoline. That's what planets do. The Earth isn't being pulled by the sun, it's just following the curve that the sun has made in space-time.
This totally new vision of gravity predicted things that sounded like pure science fiction at the time. It said that gravity could actually bend the path of light, that time itself runs slower in stronger gravity, and that massive cosmic events like two black holes colliding should send out ripples, gravitational waves, across the fabric of space-time itself. I mean, these were just unbelievable ideas.
So yeah, these were incredible theories. But in science, a cool idea is just an idea until you can test it. So how do we actually know any of this is true? Well, the proof didn't happen overnight.
It was built piece by piece over more than a century. It actually started even before Einstein in 1887 with an experiment that first showed light speed was constant. Then came the big one. In 1919, an astronomer named Arthur Eddington photographed a solar eclipse and saw starlight bending around the sun, just like Einstein's theory predicted. It was huge news. Later, in 1938, an experiment directly proved that moving clocks really do tick slower. And then, the final, stunning confirmation. In 2015, a full century after the theory, we directly detected gravitational waves from two black holes colliding a billion light-years away.
Yeah, those early experiments were absolutely foundational. Michelson-Morley showed light speed was the same in all directions. Then Kennedy Thorndike showed it was the same for different observers. And finally, Ives Stilwell gave us the smoking gun, that time dilation was a real measurable thing. It was just one nail in the coffin after another for the old physics.
Okay, I know this all sounds very cosmic and far out, black holes, the beginning of the universe, but here's the thing. Relativity isn't just an abstract idea. It has a direct and absolutely crucial impact on your life every single day. So many of our most advanced technologies, from particle accelerators to electron microscopes, rely on Einstein's theories. But the absolute best example is something millions of us use every day without a second thought: the GPS in your phone. Without relativity, it just wouldn't work.
So how in the world does relativity affect your GPS? It all comes down to a tiny but critical time correction of just 38 microseconds per day. 38 millionths of a second. It sounds like absolutely nothing, right? But if your GPS didn't account for that tiny difference, its calculated position would be off by about 7 miles within a single day. It would be totally useless.
And what's so amazing is that this correction is a real-world mashup of both of Einstein's theories. Because the GPS satellites are moving so incredibly fast, special relativity says their clock should actually tick about 7 microseconds slower each day than ours down here. But because they're way up high in weaker gravity, general relativity says their clock should tick about 45 microseconds faster. You do the math, 45 minus 7, and you get that magic number, 38 microseconds. The entire global positioning system depends on it.
So when you boil it all down, the key thing to remember is that Einstein didn't just add a little something to Newton's physics. He completely replaced its foundations. He threw out the old idea of separate space and separate time and gave us this unified, dynamic, and much, much weirder four-dimensional space-time.
And that kind of leaves us with one final big question to think about. Einstein's work proved that even a scientific worldview that stood unchallenged for centuries could be completely overturned. So it really makes you wonder, doesn't it? What fundamental idea, what accepted truth that we all take for granted today might be the next one to fall?